Problem number 66, and this question asks for find the formula of an acceleration in terms of m1, m2, and theta. So let's start. In order to solve this problem, we have to draw the free body diagram for both mass 1 that is hanging and mass 2 that is on incline. Mass 1 has a force of tension from the rope that is attached, as a field force gravity exists causing a downward force of Fg1. Let's look at mass 2. Mass 2 also has a force of tension towards the left from the rope, and it also experiences a perpendicular normal force by sitting on an incline. And the field force gravity also acts on it, but at an angle due to the incline.
Alright, so once you finish drawing your free body diagram, we're going to start writing the sigma F statement. So first I started by writing the statement for the forces in the x direction for the first block, which is the one on the incline. So you have the mass of the first block times acceleration. And then you split up the sigma F into force of tension that's pulling on the first block minus force of gravity times sine theta. And you use sine theta because when you draw out your triangle, you'll see that wherever you put theta, the force that is going in with the x direction would be the force you want, which becomes Fg sine theta. And then I just set force of tension equal to mass 1 times acceleration plus mg sine theta, and I just split up Fg into mg. Alright, so for our second sigma F statement, we're talking about the forces in the y direction of the second block. So we're going to have sigma F of the second block in the y direction equal to mass 2 times acceleration. And then we can split up the sigma F into force of gravity on the second block minus the force of tension, which is the force that's pulling upwards on the block. And then that's equal to mass 2 times acceleration. And then from here I split up Fg into m2g, and then I set everything equal to force of tension. So you get the force of tension is equal to m2g minus m2a. So for the last part of this problem, you just take the two equations that you have. Since they're both set equal to force of tension, you can just set them equal to each other. So you get force of tension is equal to m1a plus m2g sine theta, and that's equal to m2g minus m2a. And then from here, I just added m2a onto the left side, so I have m1a plus m2a, and I did that because I want to get a on one side, and then that is equal to m2g minus m1g sine theta. And from here, you factor out acceleration, so you get a times mass 1 plus mass 2, and then that's still equal to, then I factored out g, and you get g times m2 minus m1 sine theta. And now you want to get acceleration by itself because you're looking for an equation for acceleration, so you just divide by mass 1 plus mass 2 on both sides, and your final equation comes out to acceleration is equal to g times m2 minus m1 sine theta divided by mass 1 plus mass 2.